The diagram shows the curve y equals 2 to the x minus 3. Describe the geometrical transformation that transforms the curve y equals 2 to the x to the curve y equals 2 to the x minus 3. State the y-coordinate of the point where the curve y equals 2 to the x minus 3 crosses the y-axis. Find the x-coordinate of the point where the curve y equals 2 to the x minus 3 crosses the x-axis, giving your answer in the form log a of b. The curve y equals 2 to the x minus 3 passes through the point P62. Use logarithms to find the value of p correct to the three significant figures. Use the trapezium rule with two strips, each of width 0.5, to find an estimate for the integral of between 3 and 4 of 2 to the x minus 3, giving your answer correct to three significant figures. So I've got the summary of the question here. So let's have a look at part 1 first of all then. We've got the sketch of the curve above. Okay, so let's have a go. I've actually put in the curve y equals 2 to the x as well, for the sake of completeness. So describe the transformation from y equals 2 to the x curve, here it is here, to y equals 2 to the x minus 3. Well, it's a translation, isn't it? Vertically downwards, a distance of 3 units. So let's write that down then. So it's a translation downwards, a distance, I'm going to put vertically in for some reason, I just want to emphasize that, vertically of 3 units in the y direction. Something similar to that thought, with the thought of it being a translation, isn't it? Okay, that's part 1. State the y-coordinate where y equals 2 to the x minus 3 crosses the y-axis. Well, that would be when x is 0. So part 2. So x equals 0. That gives y is equal to 2 to the 0 minus 3, which anything to 0 is 1. 1 minus 3 is minus 2. So that's part 2. Part 3 then. Find the x-coordinate where the y crosses, the curve crosses the x-axis, as log a of b. So here y equals 2 to the x minus 3. When does it equal the y value equal 0? So we'll find that when it cuts the x-axis. Well, that would be when 2 to the x is equal to 3. And that implies, if you write down the equivalent log here, the 2 comes down basically to become the base. The x has got nothing holding it up, so it drops down to ground level. And you can simply write 2 of 3. If you want to unwrap a log, all you do is you swing this around. Think he's on a swing, and it hits that back in the air. You get back to this line. So x equals log base 2 of the number 3. Part 4 then. Y equals 2 to the x minus 3 passes P62. Find p to three significant figures. So number 4. Here, the y value is 62, is equal to 2 to the x minus 3. Move the 3 over then. We get 65 is 2 to the x. And now we can do the same thing again. This 2 swings down to be underneath, to be log 2 of 65. And the x value is equal to that, isn't it? Read it from right to left. Because when the 2 swings down, the x just goes down to ground level, and it's log base 2 of the number 65, which equals, so let's get that to three significant figures then. Log 2 of the number 65, 6.02 to three significant figures. 6.02, and that was to 3 sig figs. So that's part 4. Now all that remains is to do part 5, which is the trapezium rule, to work out this integral between 3 and 4. So the integral between 3 and 4 of 2 to the x minus 3 dx is equal to what? This is part 5. we're told to use the number of strips is 2, and the strip width h is equal to a half, wasn't it? That's what it said in the question. Part 5. 2 strips of width 0.5. There we go. Or is it D? Let's get the formula then from the formula booklet. Here it is here. Now that's right. So we got the formula here. Again, we can confirm that the strip is a half, strip width. N is 2, B is 4 and 3, so it's 4 take 3 is 1 over N, which is 2, that's a half. So H is a half, as it says. H over 2 here, so we can put a quarter here straight away, can't we? So we're just going to adjust the formula in this context here, because this is the generalized formula. N is 2, so that would be 2. Let's put that in there. Now here we only go up for the ones in between, don't we? 2 minus 1 is 1, so it's only the first y entry that we actually need to include here in this list, isn't it? That's our first and last ordinate. So that's what we've got then. So let's just move that together. And we don't need the h thing now, do we? So let's get rid of that. So there's our formula then, that's what we need to work out. So let's have a go then. So here we need the x ordinate, so x0, x1. We also need x2, of course. So we start with 3 and we go up. Strip width is a half, so that's 3.5. And this is 4. The y values is 2 to the x. X is 3 minus 3. That was y0. Then y1 is 2 to the x minus 3. And y2 is equal to 2 to the x minus 3. This one is 8 minus 3. 5. This one is 16, isn't it? Minus 3, which is 13. And we can leave this for a calculation, so it's equal to 1/4. y0 plus y2, so let's just add those, 18, plus 2 lots of this thing here, bracket 2 to the 3.5 minus 3, close bracket, close brace. So that's 1/4. Now I'm going to expand the bracket. This is minus 6, the second term. 18 take 6 is 12. And we've got a 2 to the 1 here, really, haven't we? So when we times the first term here to expand the bracket, we'll get 2 to the 4.5. So that's what we need to tap into a calculator. And we're working to 3 significant figures, aren't we? So it's 0.25 times bracket 12 plus 2 to the power 4.5. Come down to ground level, close bracket, equals 8.66 to 3 significant figures. 5 gets rounded up to a 6, doesn't it? 8.66. And that was to 3 sig figs.